Okay. Right. Okay, so it's back on. We want to define the term debugging. What is debugging? Anybody? It's the process of finding errors in your program and fixing them. Okay? Cool story. Remember that computers started off as big, somewhat partially mechanical devices. Back in the day when computers had vacuum tubes, which are like those kind of bulb-looking tubes that used to get pretty hot, vacuum tubes used to actually attract moths and bugs to computer systems. So debugging started like in the early days of computing, where people actually had to go and remove like a moth that might have gotten somewhere in the computer system and was causing it to behave erratically. So debugging actually came from the process of removing actual bugs from your computer system. Of course, as computers became more software oriented, once your computer system was not working, once your software was not working as it should, they called it buggy. And of course, to fix that, you still had to debug. State how each of the following can be used to create maintainable code. How can indentation be used to create maintainable code? Ezekiel. Brings you with us? Okay. Chelsea, are you with me?
Yes, sir.
All right. So how can we use indentation to create maintainable code?
So honestly, I didn't reach there in the exam, but I think it would
That's
make
fine.
it. I think it would make it more
More readable. All right.
readable. Yes, so that's what I'm looking for.
All right. So indentation. Oops. All right. Indentation helps readability by showing the blocks of control um, within code. Okay, so when you debug code and sorry, not when you debug code, when you indent code and you show what statements are under the control of other statements, that helps for somebody to read it easily, that helps somebody to understand it easily. David, comments. What are the purpose of putting comments in your code?
So that the programmer could would have an idea of what is the specific section is supposed to do,
So that the what?
so that the programmer, when is the checking over, they have written form of what it is supposed to do,
Yes.
what is the part of
So
the code supposed to do.
yes. So this helps other programmers to understand code um, quickly and easily. So if you're working on somebody else's code, there are two ways that you could understand it. You could read through what they did and get used to what they was doing, and that's to take time. But if you as a programmer might have put some if you as a programmer might have put some easy to understand plain English comments inside of your code, it helps with being able to understand the code really easily. Right? Natalia, are you there? Natalia? Okay, is Ezekiel back?
Yes, sir.
Okay, Driggs, tell me how does descriptive variable names how does descriptive variable names help to create maintainable code?
So you could say it could help other coders to be able to understand what each variable will hold or what it's doing.
Exactly, yes. This helps future coders / programmers to understand the purpose of each variable. Right, so this helps future coders and programmers to understand the purpose of each variable. And that's it. Right? Okay, so write a set of C statements. This is not a whole program they're asking you for. Okay, they want a set of C program statements that allow a user to enter timings for a traffic light until all entered values are valid. Timing values are to be entered for the number of seconds the light is red, green, and orange, are referred to as red time, green time, and orange time, respectively. Validity rules for entering timings are as follows. Red time must not be less than the sum of green time and orange time. Orange time must not be less than 5 seconds, and green time must be greater than 4 multiplied by the orange time. So if the timings are valid, the program should output timings are valid and exit. If timings are not valid, the program should output invalid timings. Please re-enter and accept a new set of value. All right. So this is, it seems a little much, but this is actually quite a simple assignment that or question that CXC has provided here. All you are doing essentially is validating some values entered. All you're doing is validating some values entered. So you need to make sure that you read some values into 3 variables called red time, green time, and orange time. So we have int red time, and this one here, however, this must look like C statements. Don't write pseudocode statements for this. So we have int red time, green time, and orange time. And what we want to do is, the first thing that we want to do is we would want to prompt the user to enter values some seconds into red time, green time, and orange time. So we have int red time, green time, orange time. We have printf statement that says please enter your red time, red light time, comma, orange light time, and green light time, respectively. Okay, so we prompt the user for the orange light, the red light time, and the green light time. And then the next thing that we do is that we have to scan them in. So scanf, and to scanf, we will have to do %d, comma, %d, comma, %d. And we're going to save it into the variables red time, green time, red time, orange time, and green time. Everybody with me so far? Everyone with
Yes.
me? So far? Yeah.
So
All
you
right.
can have the put in a do while loop.
Sorry?
A do while loop because it have if the time is not valid, you have to put this down the thing and please re-enter and then accept a new set of values.
Well, yeah, you could put it in a do while loop, or you could put it in a while loop, which will allow for which would allow for this to be asked again at the bottom. So either one is fine. If you did it in a do while loop, that's fine. You done?
Oh, is it?
Yeah. So either one is okay, right? So you could do this, and I might just have to make this text a touch smaller, and then we go underneath here, and we have to check the criteria, right? So we have some validity rules. We have some validity rules. We say while what? What are our rules? Red time must not be less than the sum of the green time and orange time. So while red time is less than green time, right? While red time is less than green time plus orange time, ORNGE time. And what else do we have inside of here? And what else? Orange time must not be less than 5 seconds. Right? So orange time must not be less than 5 seconds. So and orange time is, sorry, not and, but or. Right? So because all of these rules must be not true for it to be valid. So if red time is less than green time and orange time, or if orange time, right? If orange time is less than 5 seconds, or if green time is greater than, or sorry, if green time is less than, if green time is less than orange time multiplied by 4. So while red time is less than green time plus orange time, or orange time is less than 5 seconds, or green time is less than, or sorry, no, this has to be greater than, or green time is greater than orange time multiplied by 4. If any one of those things is true, then it means that the timings are right. Let me just make sure that my logic is sure here. Red time must not be less than the sum of green time and orange time. So if red time is less than the sum, right? Orange time must not be less than 5 seconds. So if orange time is less than 5 seconds and green time must be greater than, right, 4 multiplied by orange time. So actually if green time is less than 4 times orange time, okay? If these things do not hold true, if any one of these do not hold true, then what is going to happen? Then we have to print, right? Invalid timings, please re-enter. Invalid timing. Please re-enter. And then what we do inside here is that we print back the same statement that will allow us to read this,
Well, a while
sorry,
at the statement inside. You can't just do a while with a if statement inside.
a while with an if statement inside. Well, you see, a while is like an if statement, but a
Right.
while is an if
Instead,
statement that allows for the.
so instead of
Right.
having to write, please enter that and all that, you'll just have the while with that inside of the while, and if the criteria are met, or if the criteria aren't met, you put the invalid timings. If it is met, you put the valid timing, and then you say
Or
while you
and
put
allow it to
while
break
the
out of the
thing is
while.
invalid. Pardon?
Okay, yeah, I could see that working. I could see that working as well. Right? I could see it working, yes. So you have a variable that allows for a while to automatically enter, but then that's like doing what Aidan said at the beginning and using a do while loop.
Okay.
All right. And then at the end here, you can have a printf statement, printf, saying timings are valid. Okay. So what we do here is that we enter the red light time, the orange light time, the green light time. We store it in the variables accordingly. We say, okay, if red time is less than green plus orange, or if orange is less than 5, or if green is less than orange by 4, if any one of these are true, then it's invalid. And we prompt to enter the time again, and we keep on getting that prompt until we enter it correct. Once we enter it correctly, it will print out timings are valid. Now, this is not the only way to do it. How you propose Aidan or how you propose Chelsea, those are possible ways to do it. Okay? So there is no one correct way to write this answer here, but it should work logically, it should work just like how we have it here. Okay? Hold 1 second, please.
So I have a question.
Please hold a second, please, Aidan. Yes, sorry about that, Aidan. Yes.
So they go penalize you if you write full code?
No, but you're wasting time. So if they put this here and they give you that little area and you're trying to squeeze in, a full include stdio.h and all kind of stuff, you're wasting time, and you're giving CXC more reason to just find something that's wrong. What they say here is just to write a set of C program statements. So just write C program statements. When they want you to write a full program, they would say write a C program.
Okay, sir.
Okay. All right. So we have this code segment here, and we say we have 3 syntax errors inside of this code segment. We have 3 syntax errors inside of here. Describe the error and rewrite the line correctly. So where are our errors? So we have the following code segment. Where are our errors inside of here? I almost feel like we have more than 3.
The comma
Huh?
between I and J in on the first line.
Right, so we're missing a comma here. What else do we have?
So the second line, they just have more than.
Less than.
They missing the thing in front of it.
Right, so we should have I is less than or equal to 3. And what else do we have in terms of an error?
The curly brackets, listen.
Right, yeah, I would say that that's one. The curly brackets need to be there. Right, so we should put some curly brackets after the for loops. Any other errors? I'm seeing.
The third line, they have J equal J plus 1, and I supposed to code not C code.
Well, no, J equal J plus 1 will work in this instance actually, because remember J plus plus is shorthand for J is equal to J plus 1. Alright?
In the fourth line, it's missing the comma, and I think the ampersand after the
Right.
gosh,
So
yeah.
the comma is required. The ampersand is not required. The ampersand is only required on a scanf line. And then we have another error. We have one last error.
The backslash n is not in the quotation mark.
Yes. So we should have had quotes around this backslash n. So we had a whole bunch of errors inside of here, right? CXC said identify the 3 syntax errors. But that is more than 3 syntax errors inside of here. We have 1, 2, right? Maybe we could forgive the brackets, but 3, 4. We had at least 4 syntax errors inside of this. If you count the brackets, then we have 5. All right. So let's just write them out. We said at line 1, we needed a comma. Line 1, comma between I and G. Line 2 was the I missing from middle part before what you call this thing, the less than or equal to sign, less than or equal to 3. All right, so what's on line 3? Line 3 is what? Line 3 is, okay, line 3 didn't really have any major error, right? So line 3, line 4 is comma missing before J in printf statement. And then we had line 5 with quotes missing around the \n. Okay? So line 5, we had some quotes missing around the backslash. And in general, we had brackets missing from after the 4 statements. So we had a whole bunch of errors. Okay? Some of you all might have SPA flashbacks with the amount of errors that
I was just going to say that too.
Okay. You folks are no strangers to having a lot of errors in code. All right. I'm sorry, I couldn't help it. All right. I'm gonna erase all of this just so that I can copy. Right? Just so that I can copy the why is this pinned here? All right. Just so that I can copy this piece of code to my library. And we want to take a look at what is the expected output of the program after the syntax errors have been corrected. So I'm going to still I'll still paste this right back here. And let's assume that, of course, that this is fixed. We have the I here, and we could pretty much work it out. So we say for I is equal to 1, I is less than 3, I plus plus. For j is equal to 1, j is less than I, j is equal to j plus 1, which is the same as j plus plus. Printf %sign the j. So we start off with I, and then we have j, and then we have output. Okay? We have I and we have j. We're going to assume that the brackets go like this. All right? So we start off with I is 1. Right? Once we're in 1, we say for j is equal to 1, j is less than j is less than I. Right? So if j is 1, but j goes to less than I, we have to print out j. What outputs here? Nothing outputs here. Right? J is equal to 1, j is less than I, j plus plus. Right? It'll stop. For j is equal to 1, j is less, it'll stop. It won't go in. Because the stop condition is the same, is actually after the start condition. So we can't print anything there. Right? So we go down to the next line. And then we say I would have gone up to 2, right? For j is equal to 1, right? J is less than I. So 1 is less than 2, you print 1. And then when you come around, j will go, so j started off as 1 here. J is equal to j plus 1 will go up to 2. And this condition is not saying j is less than or equal to 2, it's saying j is less than 2. So it stops there. And then you go down and you have 3, and you would have gone into this for loop for j is equal to 1. So j is 1. 1 is less than 3. So we can print here 1, right? And then j will go up to 2. 2 is less than 3, so it will print out 2. And then j will go to 3. But this condition can't hold true for it to enter. So that's it there. So the output here, the expected output of this algorithm is 1 and then 1 and 2 on the next line. Right? 1, 1, 2. So note that this is not J is less than or equal to I, eh? That part there. That part there is J is less than I, which means that it has to check that first before it goes into the brackets. And on the first one, where I is 1 and J is 1, it cannot go in. Are you with me there? Yeah? So this is basically saying
Yes.
for
Yeah.
J is equal to 1 to 0. That's what that line is saying there. For J is equal to 1 to 0, basically. And if you're trying to go up when your value is behind, you will never go inside. All right. So briefly state the characteristics of each of the following programming paradigms. Declarative languages are more concerned about what is to be done instead of how to do it, right? So these languages are more concerned about what to do instead of how to do it. All right. So a declarative language, you could think of a declarative language as like HTML. When you create an element in HTML, you're saying what to create. But the logic behind how it's created is not explicitly stated. Unlike a procedural language, which is where you are concerned about executing instructions, these languages are concerned with executing instructions in a logical manner, right? For procedural languages, it might use functions to be able to execute a set of instructions, right? Functions may be used. Functions may be used to execute instructions. And then the last one is a scripting language. A scripting language is a language that operates to add functionality to a larger system, right? This language is used to add further functionality to an existing system through the use of scripts. So you could have an operating system and you want an operating system to do something in terms of to execute a program, maybe at startup. You could write a startup script for the program. Or if you have a web page and you want to make that web page somewhat dynamic, you could use JavaScript. So now take HTML elements on that web page and move them around. So the purpose of a scripting language is to really and truly enhance functionality of anything that already exists. Okay? A scripting language is not it's not like a base where you can create an application in it. It takes something and it adds a feature. Okay, why is using modular code a good programming practice? Anybody? Why would we want to use modular code? If we break our code up into pieces, what are some of the advantages of doing that? Well, the first major advantage, Alicia?
It will be easier to find errors.
Yes. right? So it makes discovering errors easier, right? Discovering and fixing errors easier because depending on when the error occurs, you know what part of the code to go to. Alright, it makes discovering and fixing errors easier because depending on when the error occurs, if it occurs, let's say only when you do a certain thing like a read file or a write file, you could go directly to that. Right? It makes your code easier to plan, right? To plan for, because each module has a specific task. So if you could break down your code into specific tasks, it makes it easier to plan to create your code. And that's what we did for our SBA. We had a read file function. We had a write file function. We had an add user function. And we did it in a modular manner. So every time we wanted to extend our code, we said, okay, well, what's the first thing that I need to do? I need to be able to add people to the system. Okay, once I could add and I could write a file, then I could read back that file. Once I could read back that file, I could search for a user inside that file. If I could search for a user inside a file, I could delete a user from the file, from the system. You all understand?
Yes, sir.
All right. Right? What's a function prototype in C? Right? What's a function prototype? Anybody? Your function prototype is where you declare your function. Your function prototype is your function declaration at the top. Everybody knows what I'm talking about, right?
Yes, sir.
Yes, sir.
Yes, sir.
So it's your function declaration. We want to write a function named calcTotal that accepts two integer arguments and returns the sum of the first argument added to a 20% increase of the second. In other words, calcTotal accepts the first and second and returns first and plus 1.2 multiplied by second. So they basically gave you they basically gave you the functionality of the program here, right? Of the function that you have. So you have int, not int, but float, because we have to be able to return data type with a floating point. It returns the sum of the first argument added to 20%. So calcTotal, taking int, did they give us the names of the first and second? First, int, second. So float calcTotal, int first, int second. Right? We could simply say return what? Return first plus second multiplied by 1.2. Okay, you might want to typecast this here so that it's able to work with it as a floating point integer so that it will return the float. All right, and this is it. This is 3 marks. Easiest 3 marks you could get in life. Agreed? Everybody just stay quiet. Like I'm some kind of mad person. I just,
I'll just find a way to mess it up somehow.
nah, there's no way to mess this up. The alternative to this is that you could have always gone like this. You could have said float ret is equal to that, and then you could return ret. That's the alternative. So either way, it's difficult to mess it up. Okay, and we're not thinking about messing it up. We're not thinking about messing it up. We're not gonna mess up anything. You guys gonna do fine. All right.
So I use the int first one, and I just
Huh?
said in sum. I just say like in sum would be equal to the first plus the
Second by 1.2.
Yeah.
Right. So that's what they're looking for. They're looking for this float. So if you had int, you might get like 2 marks. Okay.
Right. So
All right. So this is the biggie question that they ask, because this is a file-based question, and this is 13 marks. Right? This is a question that will end off the exam, and that students just want to hold their head and cry for and all kind of thing. But these questions is normally be easy. You just have to kind of relax and read through it, think through it, and then you can approach it. Right? Don't let the question fluster you. A local court system is implementing a file access program for civil cases. The objective of the system is to allow the recording of specific information for reporting on a summary of recorded information. 4 items of information per case are to be recorded, namely the name of the complainant, the loss suffered, the name of the accused, and court fees. Court fees attract a 20% tax. All names consist of a first name and a last name. The final line of the file contains a hashtag for the complainant's name. A sample of the file is shown below. Note that if the case is thrown out of court, the loss and fees are both 0. Write C code to write a function that loops through the file and reads the loss suffered and the court fees for each record. Then prints the total cost payable by each of the accused person. Use the function calc total in your solution. All right? So we have calc total here. You notice that this calc total here just simply returns 20% of the second fee, right? 20% additional on the second fee plus the first fee. What's the first fee here? The first fee is this fee. The second fee is this fee. Okay? So you're running these 2 values into calc total. But we have to read this. Did they say that we were reading this from a file? Or no? No, I don't think they mentioned any file inside here, right? They didn't mention any file inside here. So this is
So it's a
reasonable.
file access program for civil cases on the first line.
Right? Oh, implementing a file access program for civil cases. Okay. So we might be reading this from using an fscanf. All right? Don't panic. But they just say write C code. They're not saying write the whole program. Okay? So keep on. All right. So first thing, file FP is equal to, we have to use a pointer, is equal to fopen cases.txt, and we will do read. Okay. Hold 1 second, please. Right, so this is the first thing that we do. All right, I'm not going to, again, if you are comfortable doing it in exams, that's one thing. If you're comfortable doing it in exams, that's one thing. But if it is that you are not, I would suggest for the exam purposes, let's use FScanner, right? So we have some setting up to do, right? We have the complainant, and what are we calling the next person, right? 4 items of information: the name of the complainant, the law suffered, the name of the accused. So we have the name of the complainant and the name of the accused. All right, so we go complainant. So we say char complainant underscore FN. We give that about 20. We'll say that we have complainant underscore LN. We give that about 20. All right. We have the accused underscore FN. We give that about 20. And we have the accused underscore LN. We give that about 20. Right, so this will store the first name and last name of the complainant and the accused. We have int, and we have the loss suffered and the court fees. So we have loss, and we have loss suffered, and we have court fees. And the last thing that we will have is that we have to have, of course, a float with because the cal total function here return the float, right? So we say float, and that float will hold the, what did we call that information there? Right, case underscore payment or whatever. And then we also have to have total case underscore payment. Everybody understand why I'm using these variables?
Yes, sir.
Right, so when I read a line of text from the file, I'm going to store the complainant first name and the complainant last name. I'm going to store the loss suffered, the accused first name, the accused last name, and the court fee. Right? And then, of course, I'll work out the case payment for that particular line. And they want us to record, right, that loops through the file and reads the loss suffered and court fees for each record, then prints the total cost payable by each of the accused persons. All right, prints the total cost payable by each of the accused persons. Odd, then I didn't have to put this total case payment or whatever, right? It's just print out the accused name and how much is payable by them. All right, so we'll go through, and then what we now say is that we'll say, okay, do what? The first thing that we want to do is we want to read everything from the line of text from the file. So we go FScanner, and we say %s, comma, percent sign S, not comma, sorry, space percent sign S, space percent sign D, percent sign S, percent sign S, percent sign D. We have to store this information into here, right? The complainant first name, the complainant last name. So we say com underscore fn, comma, com underscore ln, comma, LOS, LOSS underscore SUF, comma, accused underscore first name, comma, accused underscore last name, comma, court underscore fee. All right. We have to put an ampersand before this one, and we have to put an ampersand before this one. But when we use scanf, fscanf, we don't have to put an ampersand before any string values. That's just the way it works in C. Okay, I was trying to get all of this on the same line, but apparently I'm not, I don't have enough space. Right. So essentially what we do is that we read in the line of text from the file. We would say if strcmp, if strcmp for com underscore fn, comma, hashtag is equal to 0. What does this mean? Sorry, not equal to 0, if it is unequal to 0. What does this mean? It means that as long as the first name is not a hashtag, because look at this, right? Remember that there is, we said that, note that if the case, not the case is true now. We said somewhere that that the first name is going to be a hashtag, a pound sign, if it is that that is the last line on the file. All right, we said that somewhere inside here. Okay, the final line of the file contains a hashtag for the complainant's name. So if the complainant's name is a hashtag, which is what we have here, then it's not a valid line to read. So what do we want to do? We want to say, okay, we loop in through the file, we read the loss suffered and the court fees, and we print the total cost payable by each of the accused person. All right. So we're almost done here. This is actually almost finished with the answer. Right. So if the line is a valid line of text, what are we printing out? We could print F, or let's work out the case payment. Right. We'll say that the case payment, case underscore payment is equal to, right, we have to use what's the name of the CALC total for cost underscore suffer, comma, C underscore fee. Right? Loss underscore suffered, C underscore fee. And then we just simply, we have to print out the accused, I believe, right? Then print the total cost payable by each of the accused. So we say printf, percent sign S has to pay percent sign F to percent sign S, percent sign S. right? And this is accused underscore first name, comma, accused underscore last name, case underscore pay, comma, underscore first name, comma, underscore last name. So what it's going to say is Giuliani has to pay how much ever the case payment, $222 to has to pay $222 to John Public. Bob Sky has to pay, right, $61 to Alice Wonderland, right? Innocent one has to pay $0 to Troublemaker. That's what's going to happen. And you do this while what? While you could put back the same thing that you had in the you can put back the same thing that you had in the if statement, while CMP, right, COM underscore FN, comma, tag, right, is equal to 0. Is in equal to 0, not equal to 0. Is in equal to 0. This is the code here. This is what CXC wanted. Right here. This is it. All right. So it wasn't so bad, not so? Not the easiest 13 marks you'll ever get in your life, but you know, it's probably not as hard as you was thinking it was going to be. Could we agree on that? Everybody there?
Yes, sir.
You all understand what I did here?
Yeah. So I question, they don't have to use like any tokenization or nothing like that.
No. You see, if you went the tokenization route, that would have extended this program. And that's what I was telling you all earlier in the term, that when it comes to writing for exam, it's better to use the FSCANF method. But when it comes to writing for your SBA, in terms of making your data granular, it's better to use the tokenization.
All right, sir.
All right, so that's it. You know, feel free to wave me goodbye as we finish for today.